Hello everyone. Today's lecture covers building scalable, secure, and cost-efficient .NET Core applications using Azure Storage services, along with recommended best practices for distributed cloud systems. This architecture begins with the .NET Core app layer, which can be an API, web app, mobile backend, or a hosted background worker. In modern .NET systems, we avoid embedding credentials directly in code. Instead, the application authenticates to Azure using Managed Identity or Azure Active Directory, Azure AD. Managed Identity allows services like App Service, virtual machines, or Azure Functions to securely access storage without storing secrets or access keys in configuration files, environment variables, or repositories. This significantly reduces credential leak risks. The app interacts with Azure Storage using official SDK clients such as BlobServiceClient, QueueClient, TableClient, and FileShareClient. The first responsibility of the client is to upload or download large files, like images, videos, or logs, to Azure Blob Storage. Blob Storage is designed for unstructured data and supports 3 access tiers. Hot tier frequently accessed files, cool tier infrequent access, cheaper storage archive tier lowest cost, retrieval delay acceptable using lifecycle rules. We can automatically move older data from hot-cool archive based on policies. This helps organizations optimize storage cost without manual intervention. Once a file upload completes, the system triggers an event using Azure Event Grid. Event Grid works as a serverless notification system that broadcasts state changes like, a new file is uploaded and ready for processing. Rather than processing instantly at the API level, the system writes a task message into Azure Queue Storage to decouple components. Queue Storage handles asynchronous tasks and messaging. It ensures reliable delivery and supports millions of messages, each up to 64 kilobytes. This pattern is essential in microservices, CQRS, event-driven pipelines, and background processing systems. It prevents overload on APIs during high traffic and ensures no tasks are dropped even if workers scale down temporarily. A queue worker, implemented as a .NET Core hosted background service or Azure function, continuously reads queue messages. When it receives a message, it pulls the original file from blob storage and processes it. Processing tasks may include generating thumbnails, compressing or resizing media, extracting AI insights, parsing logs, validating file formats, running security scans, transforming data after processing. The worker stores the processed file back into blob storage if required. The metadata or processing result into Azure Table Storage. Table storage is a NoSQL key value store optimized for fast lookup operations using partition key plus row key indexing. It can hold billions of entities, making it ideal for storing file metadata, IoT telemetry, device configurations, user profiles, processing status records, search keys. For caching for secure client retrieval, the system enforces HTTPS only TLS encryption in transit SAS tokens or Azure AD, scoped access, no public exposure, using private endpoints plus VNet integration. Private endpoints ensure storage accounts communicate only over Azure's internal network, blocking public internet access entirely. VNet integration and firewall rules add another layer by restricting access to trusted subnets and IP ranges. Final summary: service purpose: blob storage, large unstructured files, queue storage, async messaging, and task decoupling, table storage, structured NoSQL lookups, and metadata, Azure files, shared folders mountable on VMs. Conclusion: by combining blob, queue, and table storage with managed identity and private networking, we achieve high scalability, async resilience, enterprise security, automated lifecycle management, cost-efficient storage governance, zero secrets. In code, this architecture is widely used in real-world .NET Core cloud systems to support media processing, IoT platforms, and distributed enterprise backends. Thank you. Let me know if you want exam notes, slides, or a flow animation next.